Hello everyone and welcome to the final Physics 211 lab simulation walkthrough. As always, my name is Alec and thank you for joining us for this semester. I know it was a bit odd, maybe a bit different than we expected, but thank you for bearing with us through this weird semester, and we're going to be wrapping things up with the talk about the photoelectric effect in a simulation for that. So as always, please go ahead and read through the theory section of this lab before going ahead and watching this video and or taking your own data. Alright, so first, go ahead and open up the simulation. Then we're going to go ahead and set the intensity of light to 50%, which I'm going to do right now. And we're going to choose an intensity of light, a short wavelength of light on the slider. And so I chose a wavelength of 150 nanometers. Do keep in mind throughout your calculations and whatnot that these are going to be in nanometers, so you should account for that in your calculations. And now we are asked to adjust the slider on the battery to change the applied voltage. So you can see I can flip the battery over here to apply a voltage of 8 volts, and I can flip it all the way backwards to go minus 8 volts as well. And we're told to adjust the voltage slowly until the current goes to 0. And what is the final voltage before the current stops? So let's go ahead and check that out here. So right here you can see the current is about 0.662, and we want to hit the voltage right at which the voltage goes to 0, or the current goes to 0. So you'll see it'll start decreasing in a minute here, and I'm going to wait until the current goes to 0, and then we'll record that voltage. Alright, so I get 0 at negative 6 volts for 150 nanometers for an intensity of 50%. So once we've done that, we're told to repeat that experiment for the same wavelength and intensities of 25% and 100%, and note the voltages in each of those cases as well. And then go ahead and fill those measurements in here, and make sure that you mention the wavelength of light that you chose for this data table here. All right, so I'm going to set the intensity to 25% now. There we go, and I'm going to set this at some random voltage up here, and we're going to drag this down again until our current goes to about 0. All right, so it's decreasing down until we get to 0. And let me double check here. Come on. You want to hit the point at which it just first hits 0. So to me, that looks like it's about negative 6 volts. So go ahead and mark that down. And then I'm going to bring this up to 100%. And then again, we'll just mark it down. Mark down which voltage gives us 0 amps here. And let's see. All right, right about there. So again, we get negative 6 volts for a current of 0 here for the intensity and of 100%, and for light of 150 nanometers wavelength. So for section 2, what we're told to do is to set the intensity to 100%, which we already have here, and to choose a short wavelength of light on the slider. Note the wavelength for later reference. So I'm going to go down to, let's say, 100 nanometers, just to make it a bit different. And now we're going to adjust the battery on the slider on the battery to change the applied voltage and to set it to a value that gives you positive current. And so right here you can see we get a positive current. Actually, we're not going to be able to zero this out, so let me choose a slightly larger wavelength here. Maybe 120. How about 124? That sounds fine. And good. Looks like I should be able to stop it if I do that. Okay. So adjust the slider on the battery to change the applied voltage and set it to a value that gives you positive current, which I've done here. Now adjust the voltage until it goes to 0, and then note the final voltage before the current stops. All right, so I'm going to bring it down, and you'll see we're decreasing all the way until we hit 0. And for a wavelength of 124 nanometers, I get a stopping voltage of negative 8 volts. Now we are asked to repeat 7 through 9 4 times, for 4 other wavelengths of our choice, and to note them each time. So go ahead and put those in here. And then we're going to repeat it for 2 different metals. Now keep in mind here that you'll see we're actually using sodium, and then we're going to pick 2 other metals to repeat this experiment for. So okay, and we'll leave the wavelengths the same every time. So here, the first one was 124. Let's choose the second one to be, I don't know, 130. Come on. These sliders can be a bit annoying. There we go. Okay, so let's find the stopping voltage for 130 nanometers. All right, so I get, oops, come on. All right, so I get 0 amps at negative 7.6 volts. Sorry, can't talk today apparently. So that was for 130 nanometers, and we'll just do a few more. Let's go up to 140. Come on. All right, 141. And I'll bring this backwards until we get a negative or a 0 voltage or current. Come on. All right, so I get 0 amps at negative 6.6 volts for 141 nanometers. And let's see, let's go up to 150 or so. 155, that sounds fine. And the stopping potential here is negative 5.8 volts. And again, make sure that you're writing all these down. And then we'll bring this up to maybe, I don't know, 160 something. Yeah, 160 on the dot. That sounds good. Okay. So let's get the stopping potential here. And stopping potential now is about negative 5.8 volts for an intensity, or sorry, for a wavelength of 160 nanometers. So I'm going to use these same wavelengths to fill in these next two tables here. So remember, the first table was sodium. The second table is going to be zinc. So I'm going to go back down to, what was it, 124 nanometers. There we go, and we'll find the stopping potential this time for zinc, and make sure that you mark that in the table over here. So we'll drag this down until we hit 0, and I'm going to speed through these next ones just so we don't bore you too much. All right, there we go. So negative 5.8 volts for zinc, and a wavelength of 124 nanometers. Now going up to 130 nanometers. Come on now. There we go. We get a stopping potential of negative 5.2 volts. I think I might have gone a little too far. Let me see. There we go. So negative 5.4 volts for 130 nanometers on zinc. Now up to 141. Remember, you want to make sure that you use the same ones as you did before. Bring it down until we get our stop. And our stopping potential is about negative 4.8 volts for 141 nanometers. Up to 155 nanometers next. Come on. Oh, I had it for a second there. Come on. There we go. All right, and the stopping potential for 155 nanometers on zinc is going to be negative 4 volts. And then for 160 nanometers on zinc, we're going to get negative 3.4 volts. All right, so go ahead and use that to fill in the table here. Now note, these all say colors. Of course, the wavelengths that I'm using are in the visible or in the UV spectrum, so they're not actually colored. But just make sure you write in the frequency as opposed to oh, this was blue, because well, they're all kind of ultraviolet to us, right, as humans. So now we're going to switch the material over to copper, and we're going to repeat those measurements once more, and then you'll be finished up for the semester. Well, after you write your lab report. All right, down to 0 volts. So for 124 nanometers on copper, I'm getting about negative 5.4 volts. And up to 130 nanometers here, set it to a positive current and bring it down to 0. All right, so I get it about negative 4.8 volts for 130 nanometers. Next up to 141. And let's see, we get just about negative 4.2 volts for 141 nanometers, and for 155 nanometers, we get negative 3.4 volts, and finally, for 160 nanometers, we get a stopping potential of negative 3.2 volts. So go ahead and make sure you mark all those down. Also, keep in mind that here we are asking for the frequency, not the wavelength, as I have measured it here. And just remember how to calculate frequency. It should be in here somewhere. Yep, c over lambda equals frequency, c being the speed of light, of course. and lambda being the wavelength, which we have right here, so you can go ahead and calculate the frequency to add all those into your tables. And make sure that you put each and every one of those measurements into the tables, and then you can go ahead and answer your data analysis and do all those questions and submit your lab report, and then go ahead and pat yourself on the back because you have just completed the Physics 211 lab course for this semester. As always, thank you for sticking with us, and if you have any questions, feel free to email me, or you can stop on my question session anytime this week. So thanks everyone, and have a great day.